Hello, my little mathematicians. Today I'm going to help you with the study guide for modules 9 through 10.2 on expressions. So let's start off. Okay, number 1 says to solve 5 squared. Now this is not 5 times 2. It's 5 times itself 2 times. So this is your base. That tells you what number to multiply times itself. And the exponent, that little number up there, tells you how many times to multiply it by itself. So I have 2 5s. And 5 times 5 is 25. Okay, here is 7 to the 0 power. What do you think that is? It's not 0. It's not 7. Hopefully you said 1. Anything to the 0 power is 1. And here's why, in case you want to test it out. Remember, you can kind of write yourself, you know what 2 squared is and what 2 cubed is and what 2 to the 4th is. Okay, so this is 2 times itself twice. 2 times 2 is 4. This is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. This is 2 times itself 4 times. So 2 times 2 is, let's actually write this out in case you need to. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, now each time you move up, notice that you're multiplying by a 2, right? So then if each time you back up, that means that you are dividing by a 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. Well, if this is 2 to the 4th, 2 cubed, 2 squared, this would be 2 to the 1, and this would be 2 to the 0. So when it falls to the 0 power, that's 1. And that doesn't just work for 2s. Let's test it with 3s. Okay, we know 3 squared is 3 times 3, which is 9. 3 times 3 is 9. 9 times 3 is 27. So each time you move up, you're multiplying by a 3, which means when you go back a step, you're dividing by a 3. So 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1, because anything divided by itself is 1. So then this would be 3 cubed, 3 squared, 3 to the 1st, and 3 to the 0. Okay, look at that. The base that had the exponent of 0 in both cases had an answer of 1. So as you can see, anything to the 0 power is 1. Hopefully you can just commit that to memory, but if you need to, remember you can work backwards to get there. Okay, we kind of already did this up here. This is saying 2 times itself 4 times, right? There's your base, and you're multiplying it by itself that many times. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, so there's me solving it. Last one, how many 12s are there? There's just one 12, which means my answer is 12. These are me solving it and getting a final answer. This one wants me to write it out in exponential form. So what is this represented in exponential form? It has a base of 8, and how many 8s appeared? 1, 2, 3, 4. So I use the exponent to represent how many times the 8 was used. There was 4 8s. Okay, here you have the base of 2/3, and you have 2 of them. Okay, and I would move on, and I would miss that question. Why did I miss this question? Isn't there not 2/3 and there's 2 of them? The reason I would miss this is because this is actually saying there's 2 2s on top and 1 3 on the bottom. That's not what I want. I want 2/3 times 2/3. But this is saying that, because it looks like only the 2 is being squared. But if I put it in parentheses, now it's saying the whole thing is being squared. This is saying 2/3 times 2/3. So those parentheses really did make a difference. Okay, without the parentheses, it's just saying 2 squared on top, 2 2s, and 1 3 on the bottom. But with the parentheses, it's saying 2/3 times 2/3. So please remember those parentheses. You're squaring the whole thing. Okay, so now you can see that, we've expanded, and then we've written it in exponential form as well. So let's see which one out of all these choices is equivalent to 3 to the 5th. Well, what does that really mean? It's not 3 times 5, as we've expressed up here. That means there's actually 5 3s. So 1, 2, 3, 4, 5 3s. Well, 3 times 3 that's 9. This 3 times 3 is 9. And then you have one more 3. Well, 9 times 9 is 81, and you have 81 times 3. Well, 81 times 3 is 243. So that means that 3 to the 5th is 243. Okay, so already I know that one's a choice, right? Because 3 to the 5th is equal to 243. Is it 15? No, that's somebody who just did 3 times 5. They have no idea what exponents mean. Okay, on this, well, let's see. 9 times 9 is 81, and 81 times 3, if I type that into my calculator, is 243. Okay, that's just what we did up at this step right here. So yes, this would end up equaling the same thing. This one says there's 1 3 right here. Then there's 2 more 3s. Okay, 2 more 3s. And then times 2 more 3s. So 2 more 3s, right? There was 2 3s in the back, 2 3s right here, plus 1 more 3. They're all being multiplied together. Well, this is 1, 2, 3, 4, 5 3s being multiplied together. Isn't that 3 to the 5th? Why, yes, it is. So this is equal to that. This is 1, 2, 3, 4, 5 3s, 3 to the 5th. So that one's true as well. Okay, we already established that one. This one is 5 to the 3rd power. So that means 5 times 5 times 5. Well, 5 times 5 is 25, and 25 times 5 is 125. Is 125 equal to 243? No, it's not. So the only ones that worked were B, C, D, and E. Okay, so always work out what this is and then see which ones match that. Okay, I think we've nailed exponents. Let's establish how good we are at writing expressions. So if the directions say write an algebraic expression, that means they want you to use math symbols to represent this word phrase. So sometimes they'll give you an algebraic expression like x plus 3 or x minus 1 or 2x minus 4. Okay, these are algebraic expressions, and these are word phrases. So I want to go from this word phrase and determine what algebraic expression is that. An algebraic expression just means it includes a variable. Okay, product means multiply. What am I multiplying? I'm multiplying 5 times some unknown number that we don't know. So I just write it as 5 times x. Okay, if you wanted to do this, sure, we just don't need to anymore. Okay, this is the grown-up way. And yes, you could do this as well. You just don't need the parentheses until you're actually substituting in a number for that variable. You can just write it like this. This is the preferred way. Please don't write it like this. This looks like times 5. We might take it, but gross. Don't do that. These are the preferred ways. We especially do not want this anymore. 5 times x. This looks like 5 times some unknown number times another, that same unknown number, which is actually 2x's, which is 5x squared. Totally not the same thing. So we want to get away from writing like that, an x to represent multiplication, because now x's are standing in place of variables. Now, if they say a specific variable to use, like here, a y, then use a y. If they don't specify a variable, then use whatever variable you want. A lot of our exams, if you're typing it in online, will probably say use the number n. But if they don't specify, you can use whatever you want. Okay, sum means add. Now, if you're struggling with these different words of which ones mean what, please utilize that last page of your packet and review those key words. So remember, that last page of your packet has a lot of these right here. Give this to a neighbor or a friend or a sibling or a parent and let them know, hey, can you read like this? How many are left over? And I have to say, oh, that means subtraction. And then you ask me splitting something up evenly. And I have to say, oh, that means division. Like read it out of order, mix it up. And you read the word phrase and I have to tell you what that means to do. Okay, and then if it's with a friend, you can swap it back and then you can quiz them. This will help you a lot if you get this down. So please review this last page of your packet. Okay, so sum, hopefully you know, is addition. If not, study that last page. And what are you adding? You're adding y and 12. Okay, quotient means divide. So I'm dividing 7 by k. Sure, that's saying the same thing. But if you're typing it online, you can't type a division sign. So you just put 7/k. Yes, it matters what's on top. Because, like, let's say it was 2 over 1, that's 2. But 1 over 2 is 1/2. That's like $2 versus 0.5 or 50 cents. Very different. So whatever comes first goes on top, whatever comes second goes on the bottom, okay, when you're dealing with quotient. The other things where order matters is subtraction, okay? If it just said 8 less a number, that would be this, okay, 8 less a number. But this doesn't say 8 less a number, it says less than a number. So whenever you see than, it moves it to the back. So it's -8. What are you taking 8 away from? Some unknown number, okay? Again, because it said than, the 8 actually went to the back. So than is an indicator that you move it and the order changes, and so is from. Like if you see less than, fewer than, or subtracted from, deducted from, that moves this to the back. Otherwise, if it just said 8 less a number, or the difference of 8 in a number, or 8 minus a number, this would be the right answer. Okay, so those ones don't change. The only one where the 8 moves to the back is when it says less than, fewer than, subtracted from, deducted from. So than and from are your indicator that, oh, it moves to the back. Okay. And again, that's on the last page, that little reminder. This is saying 8 times what? 8 times some difference. Okay, so what am I subtracting? I'm subtracting 3 and n. So difference means subtract, and you keep it in the same order it comes. 3 first, n second. This is saying 8 times the difference of some number and 19. Okay, so notice how the number came first, 19 came second. So I put it in that order because difference doesn't change. The only time subtraction order changes is if you have less than, fewer than, subtracted from, and so on. Now, if you didn't have those parentheses and you just did this, that's very different. That's just saying 8 times 3, but I want 8 times that whole difference. So this is wrong. Okay, this is wrong here. This is just saying 8 times some number, and then you're subtracting 19. I want 8 times that whole difference. So please make sure you include the parentheses for those. Okay, this one is saying, and again, remember, always try some yourself first. Pause the video, try it, and then unpause it and come back. Okay, so 4 minus the quotient. Quotient means divide. You're dividing some number and 5. So this comes first, it goes on top, and then after the word and, that goes on the bottom. Okay, this is how you would type it in on a computer, 4 minus n slash 5. If you weren't typing it in on a computer, sure, you could put this. You're doing a number divided by 5, and that's being subtracted from 4. Okay, both of those are correct. All right, go ahead and try this one. Okay, you're back with us. It said 2 subtracted from, so that means I'm moving it to the back. And what am I subtracting 2 from? I'm subtracting it from the product of 5 and w. Okay, so 5w minus 2. And that's it. Okay, now we're going to move on to you trying to, not just from a word phrase, but from a word problem, write an expression. So it says Johnny and Tim go swimming each week. Tim always swims 5 laps less than Johnny. So Tim is equal to 5 less than Johnny. Okay, 5 less than what? 5 less than Johnny. So write an algebraic expression to express how many laps Tim swims each week. So I'm trying to do Tim. Okay, well, this is representing Tim. It's Jim minus 5. Now, actually, this is the correct expression. This is not, because this is an equation, and it said it didn't want an equation, it wanted an expression. What's my variable? That's what it means by define your variable. J stands for the number of laps that Johnny swims. All right. This one is saying Sarah is organizing her socks. She has one large pile of socks and wants to divide her socks into 4 smaller piles. So I'm dividing. I'm dividing it into 4 piles. And what am I dividing? My number of socks. Okay. There you go. That's my expression. So express how many socks are in each pile. If I take the total number of socks and divide it by 4, that'll tell me how much is in each pile. So S equals the total number of socks. Now, if they don't tell me a variable to use, I typically like to use things that make sense within the word problems. Like I used S for socks, J for Johnny, T for Tim. But if they tell you a specific variable to use, then use that one. With S, I would try to stay away from using S as much as possible because S ends up looking like a 5 halfway through. So really be careful with your S's. Also, T's can look like plus signs, so do them with a little tail. Just things I've picked up from over the years, because all of a sudden halfway through your problem, variables tend to disappear and look like plus signs and 5s, and then you're like, where did my variable go? Okay, moving on to simplifying expressions. So this is where I'm going to do PEMDAS. This is basically a fraction saying top divided by the bottom. So I want to get the top to a single number and the bottom to a single number. So let's simplify the top part first. You have 12 divided by 4 plus 10 times 3 minus 3 squared. And I'm going to write PEMDAS as a reminder. Okay. Each line I want to check myself. Okay. Any parentheses? Yes, that is 30. Okay. Bring everything else down. Parentheses? Nope, they're gone. Exponents? Haha, right here. 3 squared is 3 times 3, which is 9. If it helps, actually write 3 times 3 off to the side so that you're more likely to put a 9 and not a 6. Okay. So now I bring everything else down. Parentheses are gone. Any exponents? Nope. Multiplication or division? Yes. Always go left to right. 12 divided by 4 is 3 plus 30 minus 9. Okay, parentheses are gone. Exponents are gone. Multiplication or division, gone. Addition or subtraction, go left to right. So 3 plus 30 is 33. Minus 9, you get 24. Now I had that arrow there. I probably would have, before I started, off to the side, put something over 8. So I remembered that this was just simplifying the top. Now you have that top number is 24 all over 8, right? And what is 24 divided by 8? It's 3. Okay, this one looks a little bit more simpler, but looks can be deceiving. Okay, parentheses, no. Exponents, no. Multiplication or division, yes. We don't do this first. We're actually going to do this first. Because when deciding between multiplication or division, you go from left to right. And this came first. So I'm going to do that and bring everything else down. Okay, so the 24 divided by 8 simplified to 3. And then I bring everything else down surrounding it. I like using these little carets because it reminds me now the 24 and 8 are gone. It's replaced with that 3. Okay, now parentheses are gone. Exponents are gone. Multiplication or division is right there. 3 times 4 will make 12. Now bring everything else surrounding it down. Okay, parentheses are gone. Exponents are gone. Multiplication or division is gone. I'm left with addition and subtraction. Addition doesn't necessarily always come first. When deciding between addition and subtraction, you go from left to right. So 40 minus 12 makes 28. 28 plus 6 is 34. Okay, again, remember, please be pausing the video, trying it yourself, and then coming back to check. All right. This is what I'm going to do first. And within the parentheses, order of operations still apply. So should you subtract or divide first? Division comes before subtraction. So 6 divided by 2 is 3. Bring everything else down. Okay, still have parentheses to get down to a single number, and that makes 14. Okay, parentheses are gone. Exponents are gone. Multiplication or division, right there. That makes 12. And now I finally just have 14 plus 12, which is 26. Okay, that was me simplifying with PEMDAS. Now I'm going to evaluate expressions. Evaluate basically means solve. You're going to substitute in this 6 for any r's and then solve it down to a single number. The one thing is that this is one term. R is 6, and you're going to square that 6. Okay, plus here's another term, and that's 3 times r. R is 6. And you're like, really? Why did you do this? Because it doesn't make that big a difference for this problem, but let's pretend that this was a division sign or a multiplication sign. Like I'd have to divide this first by the 3, and then I would do that times 6. But this is one single term, 3r. So I need to get this to a single number, this to a single number, and then I could do the signs between them. Again, for this problem, if you didn't focus on that, it wouldn't make that much of a difference. But in the future, it definitely can. So each term kind of put in its own brackets and get them down to a single number, then do signs between terms. Okay. All right. So 6 squared is 36. And in here, you had 3 times 6, which is 18. Now bring down the sign between them. Okay, those combine to make 54. Again, that didn't make that big of a difference, but in future problems, if you don't get in the habit of doing it that way, you might end up missing some. Okay, draw brackets around your different terms. Let's go ahead and look at this one. Okay, I have this term of 10 times k times 4 times this n minus 2. N is 7 minus 2, and k was 3. Okay, so this term simplified to 30 times this over here, this was one singular term, and I need to simplify this 7 minus 2 first, which is 5. And 4 times 5 is 20. And now I can do 30 times 20. And 30 times 20, 3 times 2 is 6. Tack on 2 zeros. There you go. Okay. 17 plus we have a term minus we have another term. Okay, this term is 5 times t. T is 1. And this one is 10 to the b power, and b is 0. Okay, so again, I'm substituting each of these in, and then I simplify it down to a single number like this. That's what evaluate means. 17 just comes down. 5 times 1 is 5. And then this term, anything to the 0 power is 1. Okay, and now I just have this. So there are only addition and subtraction left, so I can go from left to right. 17 plus 5 is 22, and 22 minus 1 is 21. Okay. A term plus some other term divided by, well, actually there's only one thing, so I guess I didn't need to do brackets for those. Okay, but in here, you have 2 times a squared, and a is a 5. Okay, b is a 2, and then this b is a 2. In here, do you multiply or do exponents first? Okay, remember before multiplying, you do exponents. So 5 squared is 25. And 25 times 2 is 50. You have 50 plus 2 divided by 2. Okay, now order of operations. I need to do division first. So that's 1. Bring down your plus 50, and 50 plus 1 is 51. Okay, I have a term divided by some other term plus some other term. So this term is 12 times m, which is 2. This is just a p, which is 6. And this term is 5 times m, which is 2, raised to the third power. Okay, so this term, 12 times 2 is 24. You can bring down the divided by 6. Plus this term, I need to do the exponent first. Well, 2 times 2 is 4, and 4 times 2 is 8, because this is saying 2 times 2 times 2. Okay, so that term I still need to work on simplifying. I have 2 cubed was 8, but now you have 8 times 5, which is 40. Okay, so that term got down to a single number. Now I can combine it with these other guys. Okay, order of operations says I need to divide before I add. 24 divided by 6 is 4, and 4 plus 40 is 44. All right, we are moving quite along. We're almost done. Hopefully you still remember how to do prime factorization. That means I'm going to break this down into only its prime factors. So how can 80 break apart? There's so many options. Okay, definitely pause the video, try it yourself, and then come back. Okay, so now you unpaused it, you're back with us. If your tree looks different than mine, that's okay. As long as you didn't make a math error, we still should get to the same final answer. When I think of 80, I think of 8 times 10. You could have done 2 times 40 or so many other options, but as long as you keep going, we'll still end the same. 8 can break apart to 2 times 4. Now I can stop with the 2, it's prime, but the 4 can keep going into 2 times 2. Prime, prime. This 10 can break apart into 2 times 5. Prime, prime. So what do you have? You have 2s and 5s. How many 2s? 1, 2, 3, 4 2s and 1 5. And there you go. That's your prime factorization. It's all the prime numbers that would multiply together to give you 80. They want it, the proper notation is the smaller bases first. So 2 is smaller than 5. And then if 2's happen more than once, use an exponent to represent any factors that appeared more than once. And how you can check to see that you're right is 1, 2, 3, 4 2's times 5. If I were to multiply this out, I should get what I started with. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And if you type in 16 times 5, you guessed it, you got 80. So I know that this multiplies out to 80, and it's made up of only prime numbers. So this answer is with confidence correct. Prime factorization, each number only has one specific prime factorization to represent it. Just FYI. Okay, this one, I know it ends in a 5, so 5 can go in. 5 times 12 is 60, so this must be 5 times 13. 5 is prime, 13 is prime. Look at that, that was easy. 5 times 13. Done. That is a prime factorization of 65. Hopefully you did pretty well on this. If you did, you know that you are definitely ready for the quiz. If not, try some extra practice problems in your packet that are similar to the ones you missed in the study guide, or sign on to Khan Academy and type in types of problems that you missed. Really review that last page of your packet that goes over the keywords and phrases. You got this. You're going to do amazing.